So let's try this problem. Now this one's a little bit more difficult, but I'm sure you guys can do it because you are smart. That's what I keep telling myself. What would you do?
I said it.
Indubitably, yes. Good old reference to Schoolhouse Rock. Gotta love it. Now, come on, Zach, just tell me the answer.
-7.5.
-7.5. Oh, man. No, not even close. Let's try this one. Now, this one's a little bit more difficult because it doesn't just equal a number. It equals a variable expression. So, we know that the insides, the 2x minus 13 has to equal what? It has to equal 5x plus 1, or the insides have to equal what? How were we doing these before? Say again?
Is it 5x -1 or -5x?
Well, what we said before is that the inside stuff is either going to equal this or it's going to equal its opposite. And so it would be negative the quantity 5x plus 1. So the inside stuff of the absolute value is either equal to 5x plus 1 or 5x plus 1's opposite. So let's solve this. What about on the left side here? What would you do? Work backwards, eh? How? Start with the answer that's given to you, right? So you start with the answer, which is -14/3, and you work your way back. Wait, what, Mr. Craig? Exactly. So instead of doing that, let's move the 2x to the right. Let's move the 1 to the left. That's what I would do. What would you get?
3x equals -14.
All right, so -14 equals 3x, which means x equals what?
-14/3.
Hey, that's right. I started with the right answer. Good job. All right. You know how difficult it is to go through life being this awesome? Maybe one of these days you will. Now, what about over here? What would you do first? Yeah, let's distribute that negative. Get that guy out of the way. Which way would you like to move your x's here?
Add 5 to 2x.
So move the 5x to the left, which means that 13 has to go to the right. So what does this look like now?
7x equals -12.
7x equals positive 12, right? Because you're adding 13 over here? Right? Okay. So then finish this guy, so x equals what? 12 over 7. Please do not try to convert this to a decimal. Please do not turn this into a mixed number. Just leave it as a reduced, simplified, improper fraction. It's okay. Now we've got to make sure these answers are correct. Do we just trust that they're correct?
Plug them in.
Yeah, let's plug them in. Yeah, you go do that. You deal with the fractions. Does it work out?
Oh, I don't know.
What do you mean you don't know?
Work it out.
Huh?
Work it out.
Work it. Okay, fine. Let's check this. Let's check ourselves before we wreck ourselves. So if I'm doing the absolute value of 2 times -14/3 minus 13, does this, I guess time's out. We have to see, are these guys equal? So here I'm going to get -28 over 3. This is going to be -39 over 3. So that gives me, what is that? Okay, fine. That's -67/3, which is going to give me a positive 67/3. Do y'all agree? Now let's see if that's the same thing over here. Over here I get -70/3 plus this guy is 3 over 3. And that equals -67/3. Are these guys the same? Right, 67 thirds is negative 67 thirds? These guys are not the same. So that's not equal. And here's a word that you guys need to learn. Extraneous. This guy is an extraneous solution. We did everything right, but because of certain limitations in the problem with the symbols that we have, like absolute value and the variables over there, we end up with a solution that's extraneous. It doesn't work out. Okay? You see how it almost works out, though. Just doesn't quite fit the bill. Now, over here on this other side, let's check this. Is the absolute value of 2 times 12 over 7 minus 13 equal to 5 times 12 over 7 plus 1? Inside the absolute value, you get 24 over 7 minus, that's going to be 91 over 7. So it's 24 minus 91. Close enough. That is negative 67 over 7. Am I tripping? Am I okay here, or am I losing it? Am I losing my mind? Which just gives me a positive 67 over 7. Is that right? Compared to this side over here, I get 60 over 7 plus 1 becomes what? 7 over 7, and uh-oh. Now we can be happy, right? Does this guy check out? Yes, this guy checks out. Is it the prettiest thing we've ever seen? No, but does it work? Yes. Now, let's check on our graphing calculator so we can see these solutions. Now, come on now. So if we go to our y equals, on the left side we have the absolute value of 2x minus 13. To do the absolute value, you press math, and then you come over here to where it says number, and we want to do the absolute value. Let's see, my format looks a little bit different than what you guys may see, so I'm going to change my mode here. I'm going to go back to the classic view of your graphing calculator. So the absolute value of 2x minus 13, and the other side I have, what, 5x plus 1? Do you all agree? So when I graph these guys, I should be able to see how many intersection points. Only one intersection point, right? Now remember, you can press the enter button to pause. We've talked about that, right? Okay, so there's my absolute value guy being graphed. Now I've got a line, and there he is. So I'm going to change the window here just so we can see things a little bit more clearly. I am too fast for my calculator. Alright, so there's the absolute value guy again, and here comes 5x plus 1. Now it kind of makes sense that we would only have one intersection point, because look at this, the slope of this guy. This has a slope of 2 for the absolute value, but the slope of the line is 5x. So he was only going to hit that guy in one spot. If the slope had been less than the 2 that we have here, he might have been able to hit more than once. But you see we have this intersection point right here, and if you remember about finding intersection points, you can press second trace to bring up your calculate menu. We're looking for the intersection, and the easy way to do this, since there's only one intersection point, is to select this first guy which says y1. The second guy is 5x plus 1, so that's good. And the guess, there's only one intersection point, so if we hit enter again, even though we're kind of far away from that, it knows to find that intersection point. Now it gives some crazy decimal here of 1.7142857. That's kind of crazy, right? Am I going to allow that for an answer? No, but watch this. If you quit, and if I were to press X on this menu, on this screen, you get that same decimal value. Even though before I graphed, I'd cleared everything out, and my X value was stored at 0, when I found that intersection point, it stores in that X value that we had for the variable here. But what am I going to do with this so that I can have the exact value? Turn it into a fraction by pressing Math. And this first option here will convert your answer to a fraction, so you press Enter, and I get 12 over 7. Well, I thought the answer was 67 over 7. What's funny? See, X is 12 over 7. The 67 over 7 was just what each side would equal when you plug in the solution. So what's my answer? 12 over 7.